Hi, my name is Matt Kuperholz. It's my pleasure to be with you this morning. And it was really great to hear the previous speaker talking about the sophistication of the Australian market. Not a very deep market for energy, but we have an incredible amount of sunfall and a lot of wind. And what I want to share with you is a project which I was very proud to work on a few years ago, building a virtual power plant from scratch. We've since leveraged and expanded on this use of technology, but I'm going to tell the original story. As the chief data scientist and as a professor of AI, I'm industry agnostic. I'm not an energy industry specialist. I've worked across all industries. In fact, I've solutioned AI for over 40 of our top 50 companies on our stock market. And with all of them, there's this idea, and it seems to disobey the fundamental laws of thermodynamics, but this idea that we can get something for nothing, or I'm not sure if it's just an Australian saying, the mythical free lunch. How do you get something from nothing? Well, when you're using data as your fundamental asset and AI as a preferred tool to create value in that data, you're creating some value, but you're not using the data up. So therefore, we can break these rules of thermodynamics. We can get more out of a system than we put into it because the resource, the asset that we're using to generate value, i.e. data, is not being consumed in that value creation process. Now, to make it even more exciting, and as Christian Kern alluded to with the 6Ds, I also am an incredible fan of this idea of exponential times and the disruption that they bring. Peter Diamandis and Ray Kurzweil of the Singularity University, and in fact, their energy specialists talk about it all the time. This idea that things aren't improving linearly, they're improving exponentially, they're doubling. So in 5 years' time, it's not going to be 5 times better, it's going to be 32 times better. And give it another couple of years and it's 100 times better. And give it another couple of years and it's 1,000 times better. So exponentiality is something we're very familiar with from the concept of Moore's law, and that hardware is improving exponentially the number of processors on a chip. Now, you can wrap your head around the fact that your mobile phone might have thousands of times more power basically disposably in your pocket than the biggest Cray supercomputers had in the 80s. But imagine when that's doubling in power every 18 months or so. What does this mean in terms of our ability to crunch this enormous amounts of data? Because data is another thing that we recognize is increasing exponentially. The volume of data, the value we can get from that data, the variety of data, these are all exponential. But if we flip the metric and you consider performance per dollar invested, you also see that storage is exponential. The cost per megabyte, per petabyte, per terabyte has been decreasing exponentially, whether we're talking about solid state storage or spinning disks or optical storage. In general, as a technological area, storage is observed to be exponential. So too are communication technologies. The cost per dollar to move information around is improving exponentially over time. Renewable energy, we've talked about this. The price per megawatt per gigawatt generated is decreasing exponentially, regardless of the technology and wherever we look, which is why it's catching up and overtaking so quickly traditional energy sources, non-renewable. We also see that batteries as a group of technology in terms of performance per dollar are improving exponentially. Our ability to store and work with data is decreasing in terms of cost exponentially, or increasing in terms of performance per dollar invested. And as a group of technologies, the Internet of Things, the micro sensors, I have one on my desk. They control my house. I get them from China for $3 each. A very powerful microcomputer, a wireless communications module, a small battery, again, a bunch of exponential technologies, really, but allowing us to connect in an exponentially cheaper way more and more devices for the machine to machine internet. I'm putting trust on this list because technologies of trust, think about to start with perhaps asynchronous encryption, and what a miracle that is, that we can securely exchange information without pre-exchanging keys. But more recently, technologies of trust like decentralized trust in distributed ledgers and blockchains and privacy enhancing technologies, these are all exponential, allowing us to trust in an ever more connected world, where trust is really getting quite broken if we think about trust in traditional agencies and governments and news and banks. Another couple of technologies, and I'm bringing up these exponential technologies because they've all actually come to be relevant and brought to bear to some extent in the solution which I'm going to talk you through. But automation, the ability to take humans out of the loop, analytics in general as a field which leverages hardware and data and computing power, and AI, my chosen field. I've been using it almost every day for the last couple of decades. We make statements like it's going to contribute as much as the current GDP of China and India put together to the global economy by the end of the decade, or that when we survey globally CEOs of major companies, 75% of them say AI is going to change their business. These are big statements, but it's a little hard to wrap our head around. So, before I deep dive a little bit more into AI, I just want to make a point that's probably already come across, which is these exponential technologies don't operate in a vacuum. In fact, they support and multiply each other. So, even though any one of them is exponential, when you've got internet connected devices and the ability to communicate with them, both improving exponentially, and you've got smart meters and other devices generating exponential amounts of data, which can be crunched even faster with exponential hardware and put AI to bear to solve these problems, it's more than exponential. It's exponential on steroids. But first, let me give a quick tip of the hat to perhaps demystifying AI because it really is a very large field. And to understand exactly what it means, you kind of have to understand what it means to be intelligent, let alone artificially intelligent. And that's quite tricky sometimes. So I find it's useful to work across two different dimensions. Um, when explaining and getting your head around AI. The first dimension is this idea of narrow AI can be on a spectrum to general AI. So, narrow AI is where it's doing one simple thing, let's say playing a game. The rules are very clearly defined. General AI, it's much more human, or perhaps in a non-anthropomorphic way, not even human. The tasks are much more general purpose. Think computer vision, think self-driving cars, a number of different things that have to coordinate together. And another dimension is to what degree are we leaving humans in the loop of this task? Now, one form of AI might be very narrow, and we've left the humans in there. It's effectively just an assisted intelligence. We get more general, but we leave humans in there, that's a form of augmented intelligence. If we're taking humans out of the loop, but it's relatively narrow, relatively simple, that's probably an automated intelligence. And an autonomous intelligence, sort of the pinnacle of how we might use AI, is that it's more general in its nature and the humans are out of the loop. And the AI application or solution I'm going to take you through is probably more in that area of autonomous intelligence. But exponential technology aside, and fast moving developments in AI aside, it's important to anchor in the fact that regardless of technology, we really only have five different types of questions we might ask. Five types of questions we might ask when it comes to creating value. We ask questions about the past. What has happened? Why has that happened? Use your data science to and use your business intelligence to tell me what's been going on. Tell me what's happening right now. Help me classify. Help me put a label on what's going on right now. What mode of operation am I in? How risky is it? Use the historical data and forecast and tell me what's likely to happen. Or if you don't have historical data, use some digital twins or simulations and answer for me what could happen if. And finally, the pinnacle of value on this traditional analytics maturity curve is prescriptive analytics, optimization. All right, the future's uncertain. Help forecast the future, help simulate what could possibly happen, and then prescribe what should I do with my scarce resources in this uncertain future to maximize some present goal. And that optimization is at the heart of this virtual power plant solution. It's also pretty much the most value we can release from data is when we're asking questions around optimization. To wrap these questions up to create value, there's four very simple steps. Let's start with some challenge. Let's apply our data assets with some AI, and then let's make sure we do something to realize that value. So let's have a look at the problem we're facing into. We want to create an automated solution, humans out of the loop. It's going to orchestrate. I love that word. It conjures up this idea of an orchestra. I'll just make myself a little bit smaller. We want to orchestrate distributed energy resources, things we're allowed to switch on or off, things which can talk to us, things which we can control. And we want to do this in order to provide cheaper and cleaner energy more reliably and efficiently to both industrial and residential customers. And while we're doing that, we want to maximize the value of the asset. We want to make sure the battery is paid off. We want to make sure the aging distribution network is not stressed through peak loads and otherwise. And we want to minimize the maintenance of our infrastructure. So it's a pretty small ask, not really. And then what about if we add to that, we want to make sure we do it in a fair, explainable, robust, secure, and appropriately governed and ethically aware way. In other words, whilst doing all these things, whilst orchestrating these DERs, whilst making energy cleaner and cheaper and reliable and more efficient, and whilst helping the aging assets and the new assets to be maximized in value, we want to do so in a way that we call responsible AI, to be fair, to be aware of the ethical framework under which you're making these decisions. But before we get into all of that, let's just prove that this is possible, because sometimes these tech geeks like me get very excited and you want to throw AI at everything. Um, is this even possible? Well, let's quickly prove with a very, very simple example on the back of the envelope that indeed it is. The very simple example is we're just talking about one day in time. There's the morning, there's the afternoon, or there's the morning, there's the evening, and there are just two households. Now, in the first scenario, let's imagine they have no forecasting capabilities. They've got no batteries. They've got no solar panels. We can't control their air conditioning. We're not allowed to switch their pool pump on or off. Basically, um, they are an old school house that says, I'm going to buy electricity when it's needed. House one has a big demand in the morning, 15 kilowatt hours. House two only needs five. The current price of electricity in the morning is very, very cheap. So they buy that electricity, and in the evening it flips around. House two is more energy hungry, and house one is less. Now you can see they're both using um, only 20 kilowatt hours, 20 kilowatts rather. And although they buy it at different times, house one is buying it when it's more expensive and house two is buying it when it's cheaper. So house one's spending 16 cents in that day, house two 9 cents. The average spend per kilowatt is 13 cents. Okay. What if they were able to forecast just in a silo? What if they could see what their demand is going to be in the afternoon? Well, house one says, "Oh, I'm going to need 15 kilowatts later, and I know it's going to be more expensive. Fortunately, I've got a battery, so my best strategy is to charge my battery in the morning and use it in the evening." House two says, "Oh, I can also see it's going to be more expensive in the evening. My demand is lower. I'm going to half charge my battery." And in the evening, they both draw down from their battery, and it ends up being cheaper for house one than before, cheaper for house two before, and cheaper on average for both of them. But what happens if they have perfect knowledge and there's some God system orchestrating between the two houses? Well, then what happens is house two is actually aware that it should buy more cheap power in the morning and sell it back to house one in the evening at a slight premium. And house one knows that it should fully charge its battery and then draw upon house two's battery in the evening. Now, what that does is it ends up with not only a cheaper cost for both houses in scenario two, but the average cost overall has dropped to 5 cents. Now, before it was 7 cents, and in the very naive system, it was 13 cents. So, by allowing the houses to orchestrate between them and to forecast price and to forecast demand, we see that we can optimize and build a more efficient system. So, now let's look at the questions that we're asking of our virtual power plant. We're saying, what has happened? In other words, can you help understand the drivers of demand and supply of electricity? But that's depends on the distribution network and the sub networks. So we actually want it by the different types and regions and segments and customers and. In other words, help me understand the past of energy usage. Um, what if we ask questions about what's happening right now? So, what are the availability and constraints on the distributed energy resources? You might have a pool pump which you're letting me switch on, but you don't want it running after midnight because it's right outside your bedroom window. So, we have distributed energy resources, but they have constraints and there are network constraints. So, we want to know what's available. We want to know the current demand. We want to know the current supply, again, by cost type, region, segment, etc. We want to answer questions about what will happen. We want to forecast future supply. We want to forecast future demand. We want to forecast peak loads. We want to forecast prices, spot prices and future prices. We want to do this with a view to the future. So we want to apply our predictive analytics to the data. We also want to build a digital twin. We want to simulate the network to allow us to test what would happen under all these different scenarios, and with different sort of configurations and different goals that are seeked in different ways. And finally, and most importantly, we want to orchestrate all of this by optimizing a portfolio that controls these distributed energy resources based on the hindsight, what has happened, based on the insights, what's happening now, based on the forecast of the future, based on the output of the simulations, considering our constraints, and all of it under an ethical framework to ensure we're doing so responsibly, which is where I'll close. So I'm only going to give this a passing note for now, the idea of responsible AI. And because we're greedy, that's not all we want. We want to build this thing in the cloud. We want it to therefore be scalable. We want to be able to scale it up or down, hopefully up, and it's actually only been in the one direction. We want to build it with a modern microservices, extensible API driven um, approach. The reason being that in the future there will be new batteries which we have to control with different devices. There'll be new device hubs. There'll be new industrial plants which allow us to control different energy consumption, supply, and demand. So we need this to be extensible. We need it to work in real time, over controlling many Internet of Things devices, and we need to be able to manage the streaming of data both in and out. To deal with this mountain of data, we know that to both forecast and optimize, we're going to have to turn to AI. And in fact, it's going to be more general purpose AI with humans out of the loop. So it's more autonomous intelligence. We want to do that for both our forecasting and optimization. We want to have access to a digital twin of the whole environment so that we can ask what if questions and try it out under different scenarios and configurations. Um, and we want to enable the owners and the users of the system to have advanced analytics, self-service reporting. As we develop this with our clients, we want it to be done so collaboratively with a mixed team, and we want to use agile development principles. I've already talked about the whole thing is overarched with this. We're going to do the right thing. We're going to do it responsibly. And finally, as a business model, we want to build this as a managed service. We want to run it for our clients, and then we finally want to transfer it over to them. So, what did we build? Let's have a look at the very highest level as to what this platform looks like. Well, there's some data flowing in to the platform. Um, there's controls out to the customers and devices. In the middle, we're going to have to do a fair amount of data work. Now, anyone who's been hands on in AI knows that um, most of the effort is getting your data right in the first place. In other words, extracting the right features and expressing that data in the right way. We then need to forecast. We're going to forecast both price and demand. Um, and then once we've got a future view of price and demand, and we know about our configuration of our devices that are connected and giving us permission to switch on and off, we optimize. And then we push that optimization out through a bunch of orchestration layers into the real world. We switch batteries, solar panels, pool pumps, industrial pumps, air conditioners, car batteries, all kinds of devices are both switched on or off or adjusted the thermostat, or otherwise the energy consumption. Some of the biggest gains earlier on were through industrial water pumps that would pump basically stored kinetic energy. So pump water up a hill to a large dam when it's empty and then run it back down the dam to do some work when electricity would be more expensive. We're switching industrial fail-safe diesel generators in the basements of buildings that essentially sat idle for that 1 in 10 year event when they needed to switch on. Well, now we can make those assets work and switch them on when it makes sense in terms of an orchestration. When the music played is going to be nice to our ears. So let's put the middle bit aside for now and let's have a closer look at the sort of data that is feeding into this thing. Literally thousands and thousands of dimensions streaming in real time. Things like the smart meter reads by household, by industrial site. Things like the weather data down to micro locations. Of course, we know how much weather drives people's desire to turn on their air conditioning and their heating, how much harder it makes certain industrial processes to run in the cold or the hot. So having weather up to the nearest minute was very important. Our energy market operators data, both the main market and the ancillary market were both fed in. We looked at the actual flows of power around the networks, and then we looked at these devices that we were controlling. What was their actual state? So that was streaming. We then had batch data about the customers, uploaded with some regularity, their tariffs, different strategies, different constraints on the network, and all the specifications for the devices, including their ramp up rates, their startup costs, and other technical details which we needed to know to actually orchestrate them. There was a bunch of adjustable stuff here, which is primarily around the preferences of both the customer and the device operator. In the middle, this data, both streaming and batched, was run through this platform, which would then orchestrate through device hubs, so multiple devices in the one home, down to individual devices, as I said, starting with things like pool pumps and air conditioning units that I can put up or down 1 degree, moving into industrial pumps and industrial generators and many different types of storage devices. We can add devices through this microservices infrastructure and keep doing it. And then also the output to the customer portal, which is where you can self-manage and self-report. Let's have a tiny look into some of these a little bit further. When it comes to forecasting, this particular data was both forecasting for the entire market and for the customer, the demand and the price. Those forecasts fed into more prepared data, which looked at the device specifications in terms of the constraints, looked at the forecast for future price and usage, and looked at the current state out of the reporting engine. And then it performed the very challenging task of optimizing. What's the best way to control these batteries, these devices, to meet the overall goal? What's the overall goal? Cheaper, more efficient energy, a more stable load on the network at all points, and better life of the assets. So multiple goals were optimized for. Of course, there was a bunch of testing, a bunch of digital twinning, a bunch of comparing expected to actual, and continual enhancement of both forecasting models and optimization models. But in the end, switched on live. It's only been growing in one direction. I was very, very happy with how it's performed. I think you'd be happy too. The entire investment of this project was paid back in a single day of operation. Quite an amazing achievement, really. And finally, I've been talking about it for a while. You can watch a whole video on it here if you want. It wasn't just Spider-Man's uncle, Ben Parker, who said, "Spider-Man, with great power comes great responsibility." It's been said many times before, and we don't get this completely free lunch without saying, hang on a minute, this system is complicated. How are we going to monitor its performance? Is it being fair? In fact, what is fair? Is it fair for a poorer household that can't afford these distributed energy resources to be paying a higher energy price because they're not contributing? Is it fair for the person with fewer solar cells to not be able to benefit from the network which they're contributing into? How do you set these tolerances? How do you set these configurations so that we're not just making the rich richer and the poor poorer? And it's not just about financial equity. There's all kinds of different ethical considerations, which there's no right answer. It depends on which society we're in. It depends how we value things. It depends on the alternatives. It depends to some extent on regulation as well. But we need to know, just because we can do this thing, how should we best do it? And that's the ethical framework that has to sit on top of AI-enabled energy solutions. And in fact, most AI-enabled solutions. We have to monitor the performance. We have to check that it's unbiased. We have to check that it's not drifting. We have to secure it robustly against cyber attacks and nefarious attacks on AI. And more importantly than ever, we have to be able to point to the decision we've made and govern the system appropriately. So that's just a teaser for responsible AI, which of course underpins everything we do. I hope this has been interesting. It certainly was a great project for me and very rewarding to create that free lunch in the energy sector and prolong the major infrastructure investments by balancing the load and helping Australia transition to renewables. And as I said before, making energy cheaper and cleaner and more efficient for all. Thank you.
But now it works. Yeah, we just had to change the setting back again. Thanks a lot for the insight, and also thanks a lot for catching up the time as you promised. So like in YouTube, this would be the 1.5x mod. Well done. We also received lots of questions. So yeah, which is basically a testament how hot the topic of VPPs are at the moment. So let's start with the first one. Please, if we could mark it. What's your experience with partners from the energy sector? Are they more on the conservative side when it comes to AI usage?
And I've got to be careful here. These are my personal views. These aren't the official views of PwC Australia or PwC anywhere, to be honest. I find most Australian companies too conservative when it comes to AI. Remember, this idea of we need some AI is completely flawed to start with. It's the tail wagging the dog. The way you've got to do it, as per one of my slides, is start with your challenge. Start with your business challenge or your societal challenge, whether that's customers, employees, supply chains, operations, finances, it doesn't matter. Start with the challenge and then realize that with the wealth of data in these exponential times, AI might be part of your solution. But put AI aside, rather, I would like to see a lot less conservatism in terms of tackling the big, hairy, audacious problems with AI and data.
Great.
Okay, let's stick to the next question on Slido. 75% of Australia's energy is generated through coal. How pressing is it to introduce AI into energy distribution? Sounds like not very.
Oh, I don't think that's particularly fair. Yes, we are addicted to the brown rocks under the ground. Yes, this is changing very quickly. It just doesn't make commercial sense any longer. We are retiring coal-powered stations. We have modelled, with a million jobs plan from Beyond Zero Emissions, an Australian think tank, we have modelled how we can actually improve our economy by getting away from coal. It's obviously a one-way journey. I think we see that all around the world, and in Australia, you see great take up of renewables. As I said before, we've got enormous amounts of sun falling on our country very reliably. We're even shipping some of that into Asia with the Sun Project, Sun Cable Project. Yes, we're coming from a relatively low base, but hopefully we're speeding up. And all I can say is it's very important to me.
Great, thank you. Then, this is now definitely a question from someone from the energy industry, because this is now very, very specific already. Why should energy providers be interested in efficient energy consumption and storage of their customers' CNT layer? How would it benefit their bottom line?
And therein lies the rub. Why should a water company try and interest you in a efficient shower nozzle? First of all, because it's the right thing to do. Second of all, because as the previous speakers talked about, energy is not very differentiated. I do think there are different colors of electrons, and we need to track those again with AI and traceable technology. In other words, I want to know if that's green energy versus otherwise. But it's not differentiated, and it is falling exponentially in price and VAT. So we need to turn to the value add services. So in Australia anyway, who owns the electrons may well own the household and the data. So what does it mean if you're allowed inside the meter and you can control things in my house? Am I then going to give half of it back to Google or Amazon? I don't think so. So it allows energy companies to move into a value add and a higher value service. When all these houses have batteries sitting on four wheels in their garages, it's going to be about the smart management of that and the distribution of value to all. So it's about seeing the writing on the wall. It's about not having a Kodak moment. And it's about realizing that the secret to salvation is actually to get people to use your traditional product less, in which case they're going to use your new products more.
Perfect. Then,
Can we make the next one?
Yeah, we have time for one more question.
Yeah. Okay. So Matt, from an investment perspective, how do you see the margin development if virtual power plants are getting a commodity status in the upcoming years?
So virtual power plants, like AI, is a concept and a whole group of technologies. They afford all kinds of different financing models for renting and buying. They include different ways of rewarding me for when I use my car or don't use my car. They really are quite unbounded in terms of ultimate functionality and the goals that we are seeking for, which isn't just the cleaner energy and the the more stable load on the asset. It's all aspects of my life that I want to be able to optimize, where power and energy is a part of that. So I don't think, I think perhaps your run-of-the-mill products are going to be commoditized. We built this thing from scratch because our client wasn't happy with what was available off the shelf. And if you think into the future with all of the functionality around financing and renewable energy and electric vehicles and all the different connected devices in my home, then I don't think this is standing still long enough to be commoditized. I may be wrong. I've been wrong before.
Yeah, perfect. Thanks a lot. So, yeah, it was great to have you on board. I think it's time that we also release you in your well-deserved evening, as I learned in the preparation. Yeah, if there's anything you would like to share later on, just send us the links and we can still disseminate it on the Bit2Match platform. So yeah, this. Thanks a lot.
Thank you very much.
Yeah,
Have a great rest of your day.
Yeah.
Thanks.
Bye.
Ciao.
Bye-bye.